All right, we're going to talk about graphing our rational functions. All right, we're going to find every little piece of information that we can from our cheat sheet, and then we're going to graph these. This is the parent function of a normal rational graph. All right, I call these boomerangs. I don't know what the proper term is for them. They look like boomerangs to me. Your asymptotes in the parent function, your vertical asymptote is the y-axis. The horizontal asymptote is the x-axis. What that means is your function gets really, really close to it, but doesn't touch it. Did everybody see that? Yes?
Yes.
Okay. So you will have some graphs that will have two asymptotes that are vertical and one that's horizontal. So your graph may look like this. There may be like a boomerang on the outside here and a boomerang on the outside here. And then inside, you could possibly have maybe an upside-down parabola. Or you could have something that looks like a snake, right? The insides could look a little different. That's when you have x to the second or third power, something like that. But it's important that you guys understand that the picture of the parabola, of your rationals, will either look something like this or something like this. Why that's important, you'll see in a second when we go to plot points. The basics of finding stuff on this is not difficult. The thing that you're going to find difficult is finding the extra points, which is really, I promise you, it's not that hard. We'll walk through it. So, like I said yesterday, the day before, whenever, this slide is exactly what the cheat sheet says. This slide says it from the math book. Your cheat sheet says it from my mouth. If you're trying to find the domain, you set the denominator not equal to 0. To find vertical asymptotes, you set the denominator equal to 0. Guys, it's very, very important that when you write, if there's a line that says vertical asymptote, you write x equals. You don't write x equals, I'm marking it wrong. It's very important for horizontal asymptotes that you write y equals. If there's no y equals, it's wrong, because there is a huge difference between a vertical asymptote and a horizontal one. If there is a slant asymptote, you would use long division. Remember, the only piece of that we want is the mx plus b part. Remainder doesn't matter. When I say to find the y-intercept, evaluate f of 0, that means plug 0 in for x. To find the x-intercept, you set the numerator equal to 0. And then to find any holes, you factor the numerator and the denominator, cross out whatever they have in common, and set that piece equal to 0. So we're going to do 2 examples today. And then obviously over the next 3 or 4 days, we're going to do a bunch more examples. So if today is a little wishy-washy for you, do not fret, I promise. This is what a question on your test for part 1 will look like. Graph this rational. And then I'll tell you, find me all the stuff. Find me the domain, the range, that sort of thing. Not range, I'm sorry. So the first thing we're going to do is we're going to find the domain. To find the domain, I'm going to do this every time. I'm going to go back to the cheat sheet. This is what I want you guys to get in the habit of doing. To find the domain, what do we do? Tell me. Set the denominator not equal to 0. So the denominator is x minus 2. So for the domain, I'm going to say, okay, x minus 2 cannot be 0. So when I solve this, I add 2 to both sides. So x cannot be the number 2. That means that every single number in the world but 2. You need to write your domain in interval notation. So it would be anything from negative infinity to 2, and then from 2 to infinity. Does it include 2?
No.
No. So you have to have parentheses on that number, and you have to tell me that there's a union. It's this part and this part. So your first line on your test would be negative infinity to 2, comma, 2 to infinity. Now the next thing, stop me if you have questions. The next thing says vertical asymptote. Okay, so go to your cheat sheet. What do you do to find the vertical asymptote? So this is what I expect to see on your test. You guys are going to write vertical asymptote, okay? X minus 2 equals 0. Add 2 to both sides, so your vertical asymptote is at x equals 2. So you write VA, x equals 2. Everybody with me? Horizontal asymptote. What do we do? How do we find the horizontal asymptote? What's the trick or whatever? What do we look at?
The highest degree.
Look at your degrees. What's the degree of the numerator?
1.
1. What's the degree of the denominator?
1.
1. They're both x to the first power. So to find the horizontal asymptote, I would say the numerator degree is 1. The denominator degree is 1. Is 1 greater than, less than, or equal to?
Equal to.
Equal to. So on my cheat sheet, if it is equal to, what does it tell me to do? If the degrees of the leading coefficient are the same, you take the leading coefficient of the numerator, which is 5, and the leading coefficient of the denominator, which is 1. So you would say y equals 5 over 1, which is the same as y equals 5. Does anybody have questions about that? Mm-hmm. Okay.
It has to be.
Hold on one sec. The question was, where did I get the ones from for the numerator and the denominator? It's whatever power that x is raised to, the biggest one. Since you don't see a number, you just assume it's the first power. Yeah. Good question. Isabella?
If you have like 3 minus x, you still use x, right? You
Correct.
use 3.
Yeah, you can just rewrite it in standard form. All right, we're moving along. We're doing well. We're doing well. Long division. I have to use long division to find my slant asymptote. You guys want to know a little trick about long division?
Miss Meadows?
Yes.
Sorry, I just have
You're
one
fine.
question. If you have like x squared plus x or something, do you use the highest x?
Always the highest. Yep.
Okay.
All right. In order to use long division, the denominator has to be 1 degree less than the numerator. Like I can't, this says 5x divided by x minus 2. If you were to divide this, think about it, first term into first term, right? X times what would give me 5x?
5.
5. When I am doing my long division and I need my slant asymptote, I have to have an x as the first term because it has to be in y equals mx plus b. A slant asymptote has to be on a slant. If you just got y equals 5 is just a horizontal line, which is what our horizontal asymptote is. So not every single problem that you do will have a slant asymptote. If the degree is 3 in the numerator and it's 2 in the denominator, then yeah, you can divide into it. The numerator degree has to be 1 bigger than the denominator. But you can look at that here. So in this case, if I talk about a slant asymptote and there isn't one, you write the word none. Don't leave it blank. Because then we just assume, oh, you don't know it. And you guys do. Again, if you're sitting here like, what? Just relax a second. Let's work it out, and then we'll talk about it. Next thing I look at is y-intercept, okay? So y-intercept. How do you find the y-intercept? How do you find the y-intercept? Plug in 0 for x. Okay, so my y-intercept. It's 5x over x minus 2, right? That's what our function is. So I have 5 times 0 over 0 minus 2. So I have 0 over negative 2. So what's my y-intercept? When I plug in x for 0, I get 0 for y. So it's at the point 0, 0. That looks weird. X-intercept. How do you find the x-intercept?
Set the numerator equal to 0.
Okay, so x-intercept. My numerator is 5x. 5x equals 0. Divide by 5. X equals 0. So what happens to be my x-intercept? 0, 0, right? And then the last thing I need to define are the holes. Remind me again, how do you find holes?
you factor both the numerator and the denominator.
Mm-hmm.
And then you cross out the similar factors that they have.
Okay. Is there anything I can factor and cross out here?
No?
No. So do I have any holes? None.
None.
Now comes the graphing part, all right? This is the part that can get a little tedious. You just have to pay attention to what you're doing. My vertical asymptote is at x equals 2. So I'm going to go right here where x equals 2, and I'm going to draw my dotted line. This is an asymptote. It gets very close to this but doesn't touch it. That's your vertical asymptote. Where is my horizontal asymptote?
5.
At y equals 5. So I'm going to go up to y equals 5, and I'm going to draw a dotted line here. What else can I plot? Do I have any other points?
Would you do the domain?
No. What other points do I have?
Y-intercept?
I have the x and y-intercept. It happens to be right here at 0. Now, you guys, this is where you have to figure, whoops, is my boomerang going to be up here? Is it going to be here? Is it going to be here? Is it going to be here? Right? It's going to be, there's going to be 2 of them, and they're going to be somewhere. We have to figure out where they are. This is the part that for some reason this makes everybody go a little crazy, and I'm not really sure why. Use your vertical asymptote as your dividing line. Okay? Everybody see this vertical asymptote right here? Do you see numbers to the left of it? You see numbers to the right of it, yes? Yes or no?
Yes.
Okay, pick a number to the left of the vertical asymptote. Just pick any negative number you want. I don't care.
-2.
Okay, -2. So we're going to plug in -2. We're going to find f of -2. We're finding a point, guys. So I'm plugging in 2. When I plug in 2, let's see what value I get out. So I'm going to say 5x over x minus 2. That's my function, right? So I'm going to evaluate this function at x equals 2. So I have 5 times 2 over... Wait, did you... Okay.
Wait, what? You were supposed to put a negative?
Yeah, yeah.
Oh, okay.
Thank you. No, that's why I was like, wait a second, it's undefined because that's our vertical asymptote. I was thinking that that was my vertical asymptote. Please erase. Thank you, David. So 5 times -2 over -2 minus 2. So I have negative.
Why are you doing -2 again?
Just pick anything over here. I'll tell you one. Once, just pick any number you want. It does not matter. Pick anything to the left of your asymptote. You can pick 0. You can pick 1. I picked something over here because it was just to the far left of our vertical asymptote. Anything to the left of it will work. So I have 10 over -4, which is about how much? About 2 what? It's about 2 and a bit, yes? You guys agree with me on that?
Yeah.
Okay, it doesn't have to be perfect, but when I plug in -2, what I'm getting at is when I plug in at -2, I get positive 2-ish. So think about, if I go over to -2, where is positive 2-ish? It's about there, right?
Right.
What you're doing is you're figuring out, should this boomerang be above the horizontal asymptote or below it? So when I pick any number over here, if it falls, your x, if your y value falls somewhere in here, then that means your boomerang should be down here. If it were to fall above the horizontal asymptote, then it would be up here. When we just plugged in -2, we found it was below that horizontal asymptote, correct? Yes or no?
Yeah.
Yeah.
So I know that it's below that line, and I also know that it has an intercept of 0, 0. So I'm going to draw my boomerang like this. It doesn't have to be perfect. It has to be in the right section. If it's supposed to be below the horizontal asymptote, you need to have it below. You need to draw your boomerang so it gets close to the asymptotes but doesn't touch it. If you drew it like this and it crosses over, I would mark it wrong because that's not right. It gets close to but doesn't touch. But all you're doing is finding a general area. When we look on the right-hand side of the vertical asymptote, there's two places it could be. It could be down here or it could be up here, correct? It could be below the horizontal asymptote or it could be above it. So in this case, let's pick a number. I don't care what number you want to pick, but something over here to the right of positive 2. What's a number to the right of positive 2?
Wait, so you can slope it however you want? Like on the left side of the boomerang?
It needs to be shaped like a boomerang.
Right, but I could make it, like it doesn't have to go, like start exactly at...
No.
What is it?
No, I just
4?
make sure it goes through that wherever you plotted your intercept. If you went like this, I wouldn't mark you wrong. I'd like you to get it as close to the asymptotes as possible, but without a graphing calculator, I don't expect you guys to be anywhere near perfect.
Okay.
So pick a number. Somebody pick a number over here to the right-hand side of our vertical asymptote. 3, that's fine. So when I plug in 3, right? When I plug in the number 3, is my y value going to be down here or is it going to be up here? That's what you're trying to figure out. Where are you drawing your boomerang? So when I plug in 3 into my function, sorry, I didn't mean to make that squiggly line so big. When I plug in 3, I have 5 times 3 over 3 minus 1, right? Or 3 minus 2. Gives me 15 over 1. So guys, when I go over to 3, where is 15? Is it below the red line or is it above the red line? On the y-axis, where would 15 be? Is it above the red asymptote or is it below it?
Above.
It's above, so then your boomerang should be up here. If it was less than 5, if it was 4, then it would be down here, but it's not. It's above. They're telling you, so your graph ends up looking like this. When you pick points to pick, all you're doing is seeing, is my rational function, is it above or below the horizontal asymptote? That's it. You always pick a number to the left and the right of the vertical to figure out if it goes above or below. And the more we do this, I promise, the easier it'll get. I promise. Let's try the next one. Before you guys get all upset or anything, let's just look at the next one. Okay, we're going to follow the same steps. Same exact steps. Let's find the domain first. How do you find the domain? What do you do to find domain?
Set denominator not equal to 0.
Okay, so I'm going to say x squared minus 25 cannot be 0. Add 25 to both sides, right? X squared cannot be 25 square root. So x can be any number in the world except for what? Positive and negative 5. Now, how would we write in interval notation that x can be any number in the entire world except for those two?
Negative infinity to negative 5.
Negative infinity to negative 5. I agree. Good.
Negative 5, comma 5.
Negative 5 to positive 5.
And then 5 to infinity.
5 to infinity. Very good. You just told me you can use any number in the entire world except for positive 5 and negative 5. So if that's my domain, what are my vertical asymptotes? At x equals what?
Positive and negative 5.
X equals positive 5 and x equals negative 5. Let's go ahead and put that on our graph. All right, this graph's going to look a little different because it's x squared. So I'm going to have two vertical asymptotes. I'm going to have one here at positive 5 and negative 5. Questions on how I just got that? Everybody's okay? Okay, let's talk about horizontal asymptotes. How do we find horizontal asymptotes? What's the cheat sheet say to do?
Compare degrees.
Okay, compare the degrees. What's the degree of the numerator?
2.
What's the degree of the denominator?
2.
If the degrees are the same, how do we find what our asymptote is?
Coefficients.
Okay. It's the leading coefficient of the numerator over the leading coefficient of the denominator. What's the leading coefficient of that numerator? It's 2 over 1. So my horizontal asymptote is at y equals 2. So go ahead and go to your graph and draw your line at y equals 2. Questions? This might start to make a little more sense as we do this. All right, x and y intercepts. How do you find the x-intercept? How do you find the y-intercept? What do we do? Y-intercept, plug in what?
0.
Okay, so 2 times 0 squared over 0 squared minus 25. 0 over negative 25. What's my y-intercept? 0, 0. How do I find my x-intercept?
Set the numerator equal to 0.
Thank you, ma'am. So 2x squared equals 0. Okay, divide both sides by 2. X squared equals 0. Square root, what does x equal? 0. So your y-intercept and x-intercept are both at 0, 0 again. All right, that means your graph's going to go through there. Are there any holes? How do you know if there's holes?
Factor the top and the bottom.
Okay, factor the top and the bottom. So I have 2x squared over x plus 5, x minus 5. Anything going to cancel out?
I found this on the web.
Whoops. I bent my arm weird. Anything going to factor out? Guys, does anything factor when I have 2x squared on the top and x plus 5, x minus 5 on the bottom?
No.
No. So do I have any holes? No.
No.
So there, we went through the whole list. We found everything we needed to. Now we have to find the picture of our graph. All right, this is a little different because I have a middle section. So I'm either going to have a snaky thing in the middle or a parabola. So I'll show you how to figure it out. The first place I want you to look is right here. Do you guys see this section to the left of the first vertical asymptote? Yes or no? Do you see that section in yellow? Yes. So you're going to have a piece of a boomerang. It's either going to be up here or down here. We have to figure out where it's going to be. So the way that we're going to do that is I'm going to pick any number that I want to right here. I don't care what number you pick. Pick any number you want. What are you going to pick?
-1. Oh, wait, no.
It's got to be less than negative.
-8.
Negative what?
8.
Okay, fine. -8. So I'm going to say f of -8. That means I'm plugging in -8 to see what happens. So I have 8 times -8 squared over -8 squared minus 25. So this is 64.
2.
What did I put? Sorry. 64 times 2 is 128, right? Correct? Guys? 64 times 2, 8, 128. So we're good. And then
Yes.
64 minus 25. What's 64 minus 25?
39.
What is it?
39.
Okay, 39. All right, 128 over 39. Is that number, whatever it is it above or below 2? Does 39 go into 128 more than 2 times?
Yes.
Yes, it does. Does everybody understand that? So where should my boomerang be? Should it be above the horizontal asymptote or below it?
Above it.
It should be above it. So I'm going to draw it right there. Get as close.
Meadows,
Yes.
why is it above and not below?
Because I plugged in, my value that I plugged in was -8. So I go over to -8. Say it's here on the x-axis. 128 divided by 39 is more than 2. I don't know what. Use calculator. What's 128 divided by 39? Where's the one?
I got 3.28.
Okay, thank you. It's 3.28. So, Zoe, 3.28 would be somewhere up here, right?
Right.
So you see how that's why all you're trying to do when you do this is figure out, is it above the horizontal asymptote or below it? The exact doesn't matter. It's just, is it above 2 or is it below 2? So when I plugged in -8, was my number higher than 2 or lower than 2? And it happened to be higher than, that's why it's above.
Okay, thank you.
Yeah, no problem. So now I'm going to look at this next section. All right, I got to do this just to see if there's going to be a snake or a parabola in the middle. So I'm going to go right here in between the y-axis and my vertical asymptote. Pick a number in the pink section.
Does 0 count?
No, don't use 0 because that's going to go on it.
It has to be between the y-axis, not both vertical asymptotes.
No, because you want to check both sections to see if it's either going to be like a snake or a parabola. You got to check both. The y-axis is not an asymptote, but it is kind of like a dividing line to make sure you draw your graph correctly. So pick a number in the pink section.
-2.
-2. Okay. So when I plug -2 into my function is 2 times -2 squared over -2 squared minus 25. Okay, this is 4 times 2 is 8 over -21. You guys agree with me?
Yes.
Okay, so 8 over -21, that's a tiny little number. It's, I don't know, like there-ish. Pick a number to the right. Pick a number over here.
4.
Okay, pick 4. Try 4. $16 times 2 is 32 over 16 minus 25 is 16 minus 25. Guys, I know what the answer is. What's 16 minus 25?
-9.
-9. Does it really matter where 13 over -9 is? No, but I know it's not up here. How do I know it's not up there? If it's -32 over 9, how do I know it's not up here above the x-axis to where I would draw my snake like that?
Because it's a negative.
Because it's negative. Because it's negative. I know it's somewhere, what did we say, 4? It's somewhere down here. So if I were to draw what this function would look like, it's going to be down here. It's going to be a parabola down this way. You have to check either side of the x-axis because when you have two vertical asymptotes, it's either going to be a snake looking, could be any direction, or it's going to be a parabola. So you have to check to the left of the y-axis and to the right. And then how do you think we figure out where my last piece is? What do you think I do? Just guess? It's either going to be up here or down here. How do you think I figure it out? We're going to plug in a number that's past 5. Pick one.
6.
Okay. When I plug in 6, if the value I get is above 2, then I know my boomerang's up here. If the value I get is below 2, then I know it's down here. That's all we're checking for as a reference point. So I say 2 times 6 squared over 6 squared minus 25. 6 squared is 36 times 2 is 72, right? What's 36 minus 25? 11. 72 over 11. If you don't know off the top of your head, that's okay. Is 72 over 11, is 11 going to go into 72 more than 2 times?
Yes.
Yes. So that means it's somewhere up here. So where is my little boomerang going to be drawn? Somewhere up here, close to the asymptotes. That's all I need to see. I need to see that you guys are in the right quadrant, not right, you're in the right area, meaning above or below the horizontal asymptote.
Miss Meadows?
These are tedious. Hold on one sec, Bella. These are, I know they are. Some of you are sitting there going like, oh my God. I told you guys, complex numbers, adding and subtracting i's, that was cake. This stuff gets very tedious, and the only way that it gets easier is if you practice it, which is why I'm trying to build in several days of practice. We're all doing it. Ms. Boyd and Ms. Carver, same thing, because this stuff is hard. We know that it is. Question, Bella.
For the middle part,
Mm-hmm.
how did you know that it went through the origin, or did it?
That was from our
slow,
intercepts. That was just from our intercepts. Wherever the intercept is always going to go through that.
Okay, at least one of the lines,
Mhm.
whichever line is in that area.
Yeah.